What's up, everybody? All right, so a few more examples of fully factoring polynomials and then sketching them, just because, again, this is a tricky subject, and I thought you could use a few more examples plus a little bit more practice, which is what we'll be doing today. So let's get started. So from last time, we're going to start by dividing it by possible x-intercepts. And before I even get started, I need to figure out what are the possible x-intercepts for this particular polynomial, or for instance, what would be the possible, sometimes they're called roots. So we got this polynomial, and we're going to start with these two guys. We're going to start with the n guy and the beginning coefficient. And again, you're going to want to make sure, again, your polynomial is written in order, meaning the variables are going down in order, x cubed, x squared, x, and then your last number. But you're going to start by finding the factors of this guy. I'm going to put these on top. So we're going to do 3 and 1 are the factors of that guy. And it really doesn't matter your order, and it also doesn't matter if you put plus or minus yet, because we're going to kind of look at all the different combinations, because we're going to have to divide by a couple different factors of this guy. So there's a lot of different ways to show your work for this. Let's write the factors of this. So let's see here, 1, 2, 3 goes into that, 4 goes into that, 6 goes into that, and 12. Holy moly. So we're going to go ahead and start off by taking each of these and dividing them by 1. So we're going to do 1 divided by 1, which is 1. That's when I'm going to put my plus and minus in there. 3 divided by 1, that's also going to be 3. I'm going to put plus minus there because, again, it could be positive or negative 3. Now I'm going to do 1 divided by 2, 3 divided by 2. So 1/2 is an option. Let's see here. 3 divided by 2, that's like 1.5, but I'm going to just leave it as a fraction. Let's see here. I got to divide it by 3 now, 1/3, and then 3 over 3. Well, 3 over 3 is 1, so we already have 1, so we don't have to list that one again, so that's good. We got 1/4 and 3/4. I don't think I have any of those yet, so I'm going to list both of those. Plus or minus 3/4. All right, so we got 1/6, and then we got 3/6. 3/6 is the same as 1/2, so we don't have to list that again. So you'll save yourself some time if you reduce some of these fractions in your head. So we got plus or minus 1/6, and then let's see here, we got 12. So we got 1/12 plus or minus 1/12. And then 3 divided by 12, that's the same as 1/4, and we already have that, so that's pretty much it. So these are the possible roots, and or you can call them x-intercepts for this particular polynomial, and this gives you something to start, at least some options when it comes to dividing this down and breaking it down into its factors, so that you know what the factors are. Now, I'll be honest, strategically, we didn't go this too much in depth last time. I like to start with the easy stuff. So I like to usually start with like 1 and 3. And then if some of those don't work, then I might start getting into the fractions. And again, I use synthetic just because I find it's a lot quicker to divide these. So let me go ahead and do that real quick. So let's start with, say, 1. So let's do, we're going to try the x-intercept of 1. And then we're going to list the coefficients of the polynomial here. And again, we're checking to see if we have a remainder of 0. That's how you know it's an x-intercept. We're going to drop this down. We got 12. 1 times 12 is 12. 8 plus 12 is 20. 1 times 20 is 20. We get negative 13. 20 is 7. 1 times 7 is 7. Got 10. That's a remainder of 10. So this is not going to be an intercept of that. Let's try, for instance, I didn't even get close, so I'm not even going to really try -1. I don't think it's going to make much of a difference. Let's try 3 real quick. So 3, same idea. 12, 8, negative 13, 3. Drop down 12. We get 12. 3 times that is 36. That's going to add up, and that's going to give me 44. Oh man, we're getting into some bigger numbers here. 3 times 44, well, I know 3 times 40 is 120, plus another 12, that's 132. Negative 13 plus 132, that's going to give me, let's see here, 129, 119. 3 times 119, goodness gracious, that's going to be a huge number. You know what, you guys, that ain't going to work either. So let's see here. It doesn't look like the whole numbers are working, so it must be one of these fractions. Let's try 1/2. We'll just kind of work our way up with these fractions. So I'm going to try 1/2 here. Sometimes you are going to run into problems like this where there are quite a lot of things to pick from, and it's not going to come right away, but as soon as it does, this process does get a lot quicker. So 1/2 times 12, that's 6. 8 plus 6 is what? 14. 1/2 of that times 14 is going to be 7. Negative 13 plus 7, let's see here, that's going to be 6, right? But it's going to be negative 6. And then 1/2 times negative 6, that's going to be negative 3. And ooh, look at this. We do have a remainder of 0. Good news for us. All right, so this is going to go ahead and be turned into its polynomial form. So this is going to be 12x squared plus 14x minus 6. And again, you guys could have been doing this with long division too. Now, what to multiply it by? This is just the x-intercept, so we need the factored form of this, okay? So we need to think of something set equal to 0 that solves for 1/2. Now, when you have fractions like this, I'll give you a quick little pro tip. First of all, if it's a positive, you're going to have a minus in your factored form of it. And generally what I'm doing is I look to see like this number, the number up top is going to be the number here. And the number on the bottom tends to be the number out front of the x, okay? Because if I set this equal to 0, I would have to add 1. There's the 1 part. Then I have to divide by 2, and there's the 2 parts. So this would be the factored form of this x-intercept. So I'm going to write the polynomial like this. Now, so once we get to this point, this part should be factorable, and I'm looking at this. I could just factor this straight up right now, but I'm noticing that all 3 of these terms have something in common. They're all divisible by 2, so I'm going to make this a little easier on myself. I'm going to factor out of 2. I'll leave that part the same, but dividing each of these by 2, that would turn this into a 6, a 7, and then 6 divided by 2 is a 3. That's going to be a lot easier to factor. Now this and this, you could just leave it again the way it is. You don't have to touch those. They just kind of stick together. They're all being multiplied, right? So factoring this, I get 3x minus 1, and I get 2x plus 3 is my answer when I factor this guy. So it looks like this particular polynomial has 3 x-intercepts, and they're all fractions, right? So if I set all of these 3 equal to 0, they're all going to be a fraction roots or fraction x-intercepts. Now, if I wanted to go ahead and sketch this graph, I could do that. Right now I know from the original that the degree is 3, that's an odd. The leading coefficient is positive, so my left arrow would be down, my right arrow would be up for that tail behavior. And then I would just have to plot the x-intercepts at those spots. Sorry. So here we go. We got 1/2. So that would be between 1 and 0. We got 1/3, which is, goodness gracious, kind of like right next door to that. Holy moly. And then we got negative 1/2, which is right here. We got the arrow here. We got an arrow here. And then we just would go ahead and fill in the rest of the work. So this is going to be something probably like that, with these 2 x-intercepts being very, very close to each other because this guy is 1/2, this guy is 1/3. So obviously they're going to be really close. Let's do one last example. So for this one, we've been doing a lot of degree 3s. Let's see what we could do for a degree 4. So I'm going to break this down. So factors of this, factors of this, we'll start again. We got 27. So things that go into 27, we got 1, 2 doesn't go into it, 3 does, 6 doesn't go into it, 9 does, 3 times 9. I can't think of anything else. I think it's just literally going to be these 4 factors, right? Let's see here. With the coefficient of 1 out front, really, that's just 1. So it's just going to end up being these as my factors because 1 divided by 1, 3 divided by 1, they're all just the way they are. So here are my options: plus or minus 1, plus or minus 3, plus or minus 9, and then plus or minus 27. Strategically, I am not going to start with these big numbers. I'd rather start with the smaller numbers. So I'm going to start with just straight up 1. So I got 1 out front. I'm going to write the coefficients of this. And let's get started. So drop this down. We got 1 times 1 is 1. 2 plus 1 is 3. 1 times 3 is 3. Negative 12 plus 3 is going to be negative 9. 1 times negative 9 is negative 9. Nice. And then that's going to be negative 27. 1 times negative 27. What do you know? First try, got that to work. Nice. So I'm going to break this down a little bit. So I'm going to write this as the answer. This would be the number x squared, x cubed. So it would be x cubed, 3x squared minus 9x minus 27. And then I need to write that in factored form. Don't rush into writing x plus 1 because that's not it. You have to think of the factor that set equal to 0 would get you that. So again, think opposite. So adding 1, that would get that to equal 1. So the factored form of x-intercept to 1 is x minus 1. Now, you'll notice this, unfortunately, is not going to be able to factor down. Now, you could do something called factoring by grouping. I'm not going to get into that right now. But what I could do at this point is I could just say, all right, well, I'm not really sure what to do here, but I could just break this down again. And if you ever have to do this, all you would do is just take this guy, think of the factors of this polynomial. So almost start over with a new problem. And because this number is the same as the original, I'm still using the same group of numbers. So I'm just gonna move on as if this was the new problem, but remember that this is one of the x-intercepts for the original. So I'm just gonna continue on. For degree of 4s, you usually have to break it down twice before you can finish out the problem. So let's try 3. So I'm gonna break this down by 3. So let's go 3. I'm gonna just worry about just this polynomial part of it now. So 1, 3, negative 9, and negative 27. So drop this down, get 1. 3 times 1 is 3. Add that together, get 6. 3 times 6 is 18. Negative 9 is 9. And then 3 times 9 is positive 27. And what do you know? I'm on fire right now. Lucky again. So I got, this is my polynomial here. So this would be x squared, this would be x, this would be a number. And this should be factorable. And what I'm going to do is I'm going to add on this x-intercept, but in factored form. The factored form of this, again, think opposite to put in factored form. And I'm also going to include this because, again, I am trying to break down this polynomial, not just this polynomial. So this is where I'm at right now. So I know this is an x-intercept or a factor, this is a factor, and I just have to factor that. So I'm going to factor this real quick. So I got x plus 3. X plus 3 would be the factors of that, if I factor that correctly. And I can simplify this a little bit, actually, because I have 2 repeats. So I could actually write this problem like this. And then this would be my factored form of the original polynomial. Now, if I want to go ahead and sketch this, I could do that. This would have a degree of 4. And the leading coefficient is positive, so actually both arrows are going to be up. And here we go. So we got boink, 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 boink. Both arrows are up. And I'm going to have an x-intercept at 1, at 3, and at negative 3. And I'm actually going to have a double intercept or a double root because this has a square next to it. So that's going to bounce off this one. So it's going to look something like this. Bounce off this, go through this, go through that, and then voila, I've sketched it too, okay? So those are two quick examples. Your assignment will be, again, to continue practicing these. Now, just a quick heads up, if you're ever kind of stuck, you can get some help. And the way you could do that is you could just throw this onto Desmos, and Desmos can give you some clues as to what the x-intercepts are. And that's what you should do if you kind of get stuck. Now, in order to get full credit on the assignments and eventually the take-home test that we'll be doing, I do need to see this interim work so you can show me that you know what you are doing. But again, if you ever did get stuck, in theory, you could technically graph these so you could at least know what the x-intercepts are if you are really struggling, okay? If you have any questions, again, office hours are always Mondays through Thursdays, 1 to 2 p.m. If not, you guys have a wonderful day. Talk to you later. Bye.